Imagine you were an alien and could float through space. You had a brain shaped like a donut, and 8 arms grew out of your head. 3 hearts pumped your blue blood, and some of you might even have lethal weapons. In an instant, you could change your looks, putting on the most spectacular light shows. But above all, you were intriguingly clever. Imagine no more. This bizarre creature exists.
When you come across your first cuttlefish, they are the most amazing creatures. They're either a pair of eyes staring out of a bush of seaweed, or they're these sort of small alien spaceship, and you couldn't get a weirder looking animal underwater.
Captivated by these highly alert creatures is marine biologist Dr. Mark Norman, a senior curator from Australia's Museum Victoria.
The thing that fascinates me about cuttlefish is that they are so different from what's familiar to us. And when you dive with them and see all the things they're capable of, you just can't help being drawn to them.
Mark Norman is a world-leading cuttlefish expert. He's been tracing them for 20 years and still hasn't seen half of the 100 species believed to exist. These aliens live in oceans around the world, and they have a unique trademark which gives them their name.
Cuttlefish are a really special group. They're united by having an internal shell, a chalky shell called a cuttlebone, and this is a structure with little air gaps that helps them float in the water.
Most of us know their washed-up bones from the beach, or as calcium snacks for pet birds. Strictly speaking, cuttlefish aren't fish at all, but mollusks, soft-bodied animals without a spine. Together with their famous cousins, the octopus and the squid, they form the group of head-footers or cephalopods. While cuttlefish or sepia are the least known of the three, they're by no means the poor cousins. They are the masters of disguise. In the blink of an eye, they can change their colour or alter their shape by pushing up branches of skin to blend in with seaweed and rocks.
They've developed this skin that can do the amazing changes in colour and changes in shape. And what fascinates me the most is how different cuttlefish species have taken that basic tool that probably evolved for camouflage, and they've taken it a step further and said, all right, how can we use this in other ways?
So just what are their pyro tricks for? The tropics are home to a number of barely known species. Here in Indonesia, Mark and his local dive guide, Ronald, are on the lookout for a very peculiar shapeshifter.
Very nice place. What is the diving like? What's here? Is there coral?
Over the coming weeks, they'll search the reefs for the elusive Broadclub Cuttlefish, a species known for its striking light shows. Why the Broadclub has come up with such unique behaviour is still a puzzle.
Okay, are you ready, Mark?
Yep. After you. The first problem when you come to these sorts of tropical areas is just even finding an animal. You swim over huge areas of reef and you're probably swimming over lots of animals, but you have no idea they're there because they're excellent at camouflage.
Cuttlefish often live in favourite spots, and it's Ronald's local expertise which leads Mark to his first Broadclub encounter.
When you first approach cuttlefish, within sort of 10 or 15 minutes, you can get fairly close to them and they're checking out you as much as you're checking them out. And that's the most exciting time to sit and watch their behaviours, because after a while they get used to you and they will allow you to accompany them while they go off to catch food. And these guys have developed the most amazing way to do it.
Cuttlefish are always hungry, constantly on the lookout for a meal. Sneaking up in coral camouflage is one hunting trick. But if this fails, the Broadclub begins a mesmerising show that no other cuttlefish is known to use. Witnessing these electrifying displays for days, Mark is keen to put them to the test.
I'm very interested in this strange feeding behaviour, and so to try and understand what's going on, we need to get them to do this behaviour on cue whenever we want it to happen. By handing them live prey or decoys, they start doing the behaviour. You can start analysing what is it that sets them off, when it works best.
Mark's first offering of small crabs, their favourite food, is welcome. But it doesn't trigger too many light switches. Test number 2. Offer a bigger lure, like a toy lobster. Will this do the trick? The lobster proves irresistible, for as long as it looks alive. Once it stops moving, the Broadclub seems to lose its appetite. When Mark brings the lure back to life, the hunter promptly puts on its flicker show. But only until the lobster goes quiet again. Test number 3. Introduce a moving lure. But this candidate has had enough. It's off on its own hunt. Cuttlefish like their meals alive. So does the size of a potential meal trigger these light shows?
Well, it seems that for smaller prey or once they're well fed, they almost don't bother doing it. But with the bigger lures and the bigger crabs, the cuttlefish do a really good detailed display to sort of stun or to dazzle the prey long enough to slow them down, and then the cuttlefish could come in and nail them in the way it wanted to. In the case of the crabs, the cuttlefish wanted to grab it from behind so those big dangerous claws were out of the way of the attacker.
The secret is positioning. If you don't want to lose one of your arms, you'd better get the right grip on your prey. But back to test number 3.
The most interesting is when you offer a Broadclub cuttlefish a live animal in a glass jar. It gives you a perspective where you can move the jar around and see what it looks like from the prey's point of view. It looks like they're sort of effectively hypnotising their prey. It's fantastic. They get very excited, come in and nail the glass, get confused, the water's solid and they can't get through the water, and they continually try and get in at different angles on these glass containers.
Every single cuttlefish starts off with the same hungry determination, but Mark can't fool them for long.
They learn really quickly. It only takes a few strikes before they realise they're not getting the crab. It's a total waste of time. You can sort of see them mentally turn off and sort of drift away. You get a sense there's a hell of a lot going on in those brains, but we're struggling to kind of understand how they work.
Cuttlefish share something with us, brain power. Just as we have the biggest brains of all mammals, they have the biggest brain-to-body ratio of all invertebrates. But does this mean they're actually intelligent? Looking for answers is Dr. Jess Purdy, a comparative psychologist at the Southwestern University in Texas.
Can we know more about ourselves by studying another animal? And as a comparative psychologist, I think we can. By understanding their world a little bit can give us more insight into our world.
Cuttlefish are very foreign to us, but their brains could provide insights to one of the big questions in science, the evolution of the human mind. But first, what does it take to be intelligent?
You can talk about intelligence as learning, and learning can be defined as a relatively permanent change in behavior as a result of experience.
Let's go back a step. The Broadclub, initially intrigued by the crabs in the jar, quickly lost interest. Basic learning is measured on 3 levels.
The first thing that animals need to learn is that certain stimuli aren't meaningful biologically. They aren't going to hurt you, they aren't going to provide food for you, etc. They are safely ignored. That means that we've habituated to that. The second form of learning that we've looked at is classical conditioning, and in that situation, an animal makes an association between 2 stimuli. One stimulus predicts another. The experiment that we do with Troy, the toy fish, is actually asking that question. Can a cuttlefish make an association between this object, which is not food, and food?
Will the cuttlefish learn that this wannabe fish is just an indicator? Can they understand that Troy's only role is to signal something important? In this case, food.
The experiment as you see it looks very simple. You see somebody simply drop a toy fish in, and then a little bit later drop a fish in. But there is a whole lot going on intellectually in terms of what the animal is doing.
To prove it, a second group is tested. Again, Troy does his usual rounds, but this time the animals don't strike at him. Why? Because Troy does not predict live fish, and consequently loses his appeal. Repeated trials confirm it. The group given fish keeps on striking Troy. The others stop.
So we're seeing a difference between these 2 groups, and the difference is learning. The third thing that's important for animals to learn is the animal has to respond in order to get something, and that's called instrumental conditioning. All right, Neil, I'm going to set the equipment up.
To demonstrate this advanced level, the animals must learn a completely new trick and remember it over a period of months.
Okay, guys, we're ready to go here.
Can cuttlefish learn to use an automated feeder, like pressing a button on a drink machine, or in their world, hitting the jar to get food?
All right, there's an orienting response.
And it shouldn't just hit the jar because something moves inside. It should hit because it expects a fish to be dropped. The cuttlefish learn this task easily and have now mastered the third level.
Are cuttlefish intelligent? I'm absolutely convinced that they are. So where do we go from here? We've demonstrated habituation learning, we've demonstrated classical conditioning, and we've demonstrated instrumental conditioning. But is it the level of cognitive complexity that we think these animals are capable of? Have we seen how smart they are at this point? And I don't believe we have.
For any creature, intelligence is directly linked to its own natural world. To understand just how clever cuttlefish are, we need to look for clues in the wild. And there is one place where they put on the biggest show of their life. It's late May, and winter has arrived in South Australia. The sea temperature has dropped a few degrees, and nature seems to have slowed down at this remote end of the Spencer Gulf. While life on shore slips into the sleepy season, tempers are heating up below. Now, the biggest cuttlefish in the world, the giant cuttlefish, come to life. It's the mating season, and the giants arrive virtually overnight.
Giant cuttlefish coming together to breed is the most dazzling shows that they can do in these colour and shape changes. And it's spectacular when you see them just come to life in these big displays. It's sort of like they rip off their Clark Kent outfit and out comes Superman or Super Cuttlefish.
Giant cuttlefish can grow up to 1 metre in length. Eye to eye, the big males try to outdo each other with the most intimidating body patterns. The smaller females seem unimpressed. The rivals show off long banners and run zebra stripes up and down their pumped-up bodies. They remain at loggerheads until one of them loses stamina or confidence. Giants use a special kind of combat language, but its codes are not yet known to us.
Okay, let's try this thing. The thing to work out is how far we have to curve it, because it'll distort, won't it?
Just a bit. No, that's all right.
Now, this should
Mark
make it
Norman
smaller.
and his colleague Julian Finn are getting ready to test the giants' visual strategies.
So we've got to get less curve
Does the
now.
perceived size of their rival matter?
When I bend it this way, I should go really skinny. When I go this way, I should get really fat. This is a really good time to test that sort of combat display where the males get into these big moving zebra stripes and displays to each other. Bringing a mirror in makes the solitary male think he's getting attacked and he'll go into the full attack mode. But we want to play with the image he sees. We want to distort it so that he gets the sense it's a smaller opponent or it's a bigger opponent and see if we get a different response out of him.
Right to go, Mark?
Yep. Let's give this a go.
Could be good. Hope it's a nice day.
The trick for Mark will be to engage the single-minded males without scaring them off. But then again, what hot-tempered male can ignore a rival barely a handspan away? The question is, does the reflection of a mini-me or a super-me change their plan of attack?
I wouldn't say our first attempt was a raging success. We seemed to get every response possible. I like the idea of mucking around with the optical illusions because they're such visual animals, but I think the next step is probably to get curves that make it 2 times as big, 3 times as big, or half the size, and see if you get a more straight response, because we're just a bit too rubbery. I think we probably confused the hell out of them.
The mirror proves so attractive, even the girls take a quick look. Every year, tens of thousands of giant cuttlefish are drawn to this rocky shore to breed. These mass gatherings happen nowhere else in the world.
It's usually a very secretive behaviour in lots of other animals, including other cuttlefishes, and you're lucky to even come across breeding aggregations. But to see thousands of them here is just spectacular. And so for several months, they give up the pretense of looking like seaweed or hiding in amongst the sand or the mud, and they go, bugger it, we're just going to look fantastic, and we're going to fight with each other, and we're going to impress females, and they totally ignore us. We can sit in amongst them. They can almost sit on our head, and that's when the best displays come out.
The males turn territorial. Guarding the best rock means attracting the most females in search of egg-laying spots. And the bigger the male in his rock, the more competitors hang around, all just waiting for their chance to get to the female below. Sometimes the fights escalate, and it's all arms to combat. An inky smokescreen might be the last chance to escape serious battle wounds. But all is not lost for the defeated male. He still has a joker up his sleeve, literally.
The really interesting thing in this system is actually far less obvious, and when you first dive with them, you don't see it. It takes a while before you realise what's going on. The small males who have no chance in a contest with a big male are actually doing something completely different. They're effectively cross-dressing. They're dressing up as a female by pulling in their webs and putting on this mottled colour pattern and gliding past these big aggressive males pretending to be a female and will come into the female underneath. And what happens is, as another big male comes in and a potential conflict between these big guys starts up, the sneaker males start mating with her, successfully mate with the female, while the big guy isn't even aware of it.
To get the girl takes brawn and brains. But trying to kidnap her proves a bit too cheeky. His cross-dressing busted, the swindler promptly switches back to his male ego.
The thing that fascinates me about cuttlefish is that they've developed this skin that can do the amazing changes in colour and changes in shape. And the sneaker males that do the female impersonation is just a fantastic story of how you take that tool and take it to the next degree.
After these cunning strategies, the actual mating seems a straightforward affair. The couple meets face to face. The female has a small pouch under her mouth where she'll store his sperm. Once intertwined, the male puts his sperm into this pouch. Over the weeks, many males will mate with her, and each of them wants to be the last partner before she fertilizes her eggs. But exact timing is crucial. A lost egg means lost effort for both of them.
And then when she's ready to lay her eggs, she pulls one out at a time, passes it over this little mass of sperm, and then sort of effectively licks them and sticks them on the top of caves. And then she'll do another one 20 minutes later, and gradually over weeks, she'll lay hundreds of eggs.
Towards the end of the season, Mark and Julian find countless eggs crammed under every rocky shelter. Within 4 months, by the end of winter, the young ones will be ready to hatch. But the little giants will start out alone. The mating has taken its toll on the parents, and soon their lives will be all but over.
It looks like cuttlefish only have one mating season. It can last for up to 6 or 8 weeks, but it's only the one session and then they all die. So some burn bright and die young, some live slightly longer and die, but all of them don't live very long. So it's probably only 18 months to 2 years old is how long they live.
With such a short lifespan, it's even more startling just how clever they are. Intelligence is all about learning new tricks. Here at the Millersville University in Pennsylvania, animal learning expert Dr. Jean Bowl is figuring out just how complex the cuttlefish's behavior is.
I think cuttlefish are remarkably intelligent animals. So the issue is, am I smart enough to find out how smart they are?
For 18 years, Dr. Bowl has been running tests with cuttlefish and their famous cousins, the octopus, which initially stole the limelight.
I began with octopuses because at that time I didn't even know about cuttlefish. Octopuses love to destroy lab equipment. If they can possibly rip something apart, they will. And in terms of their performance in experiments, octopuses are unbelievably erratic. One day they'll be brilliant, and the next 5 days they'll act like they don't know anything at all.
Hey everybody, how are you today?
once I got started working with cuttlefish, they're very practical animals to work with. They're very easy and they're very engaging. And then on top of that, it looks like their brain size relative to body size is perhaps even larger than octopuses.
Anybody else want something?
In the smart stakes, cuttlefish easily keep up with the notorious octopus. But they too have their own temperament, and Dr. Boll needs to build their maze in a way that plays to the animal's natural instincts.
The real difficulty for me is to find out how to ask them so that they can tell me what they know. They're certainly not going to tell me verbally. So I have to design a clever enough experiment that their behavior can tell me what they know. And that's what's really challenging and really, in many ways, exciting.
Cuttlefish don't like to be enclosed and will always look for an escape. So the question is, how do I get out of here? Which door is not locked?
She's up next. All right. Come on, sweetie. Yep. Come on.
13 test candidates with names like Bubbles, Goofy and Crook are tested 3 times a day over several months.
Who have we got?
We got Crook.
Okay.
What time is it? 2:30?
Okay.
The quicker they find the open exit, the more they've learned and remembered the maze design.
The cuttlefish maze has a starting tube where they go in and just calm down for a few seconds.
In she goes. She's in.
3, 2, 1.
Doors open.
And then there's a larger arena, and they have to decide whether to go to right or left. And there are features in there to help them distinguish that. One door will be open to the right or left, and the other will be closed with a transparent door. So they have to learn which way to go. First, they have to learn to go left, and then later they have to learn to go right. And then once they mastered that, they have to go left. And they got faster and faster and faster at that.
Once they've learned the concept of changing directions, the trials are stepped up a significant notch.
The current problem that I'm working on is conditional discrimination learning, which is you learn to solve one maze, and then you learn to solve a different maze, and then I test the 2 mazes mixed up together. Can you remember the 2 things at once? And we have good evidence that the cuttlefish can do this. Problem-solving learning is often ordered on a scale that goes from 1 to 8, with humans at 8, and most invertebrates perhaps at 4. This would be the first demonstration of a level 5 task being solved by a cephalopod, which is truly extraordinary for an invertebrate animal.
And it's not the only breakthrough discovery. Physically, our nerves work the same way as the cuttlefish's. Their lives are very short, yet their brains are highly complex. This makes them ideal subjects for brain research, to understand how our own brains grow and decline. It could help us treat age-related diseases like Alzheimer's. And they're not only equipped with remarkable brains. Back in the tropics, with Ronald's help, Mark is tracking down his favourite, but possibly deadly cuttlefish, a creature as atypical as its murky home.
These muck dives on sand and mud areas are very different. They feel very solemn and dark and moody. You have these black plains going everywhere. The few animals you do pass are either covered in poisonous spines or pretending to be dead leaves. You get this feeling that it's just oppressed by predators.
This is a place of the weird and the wonderful, where standing out or blending in depends on whether you hunt or are hunted. Like the rare mimic octopus. But the strangest of them all is a cuttlefish unlike any other. For a start, it's walking, not swimming. and in a way that surprises even the experts.
It's still really foreign for me to watch a cuttlefish walking around on the seafloor. They'd actually look like these prehistoric lumbering monsters sort of walking through these ancient black deserts.
Only about the size of an egg, this enigmatic little critter has made a huge impression on Mark. Although it walks most of the time, it can still swim. Just. But its cuttlebone has shrunk so much, it can't keep up for long.
They seem to have a really gentle nature. They flap up into the water, they settle down again, and they go back to walking along the seafloor, back into camouflage, back into feeding almost straight away, looking for something to eat out on the mud.
Like its big brothers, this cuttlefish has to grow fast and is always hungry. But to catch a tiny glass shrimp takes very good eyesight and patience. Stalking its meal in spiky disguise, it aims its feeding tentacles like a pool player, ready to hit the target. Eat and be eaten. For every creature, there's a hunter lurking. These open plains don't offer much cover, and to be out and about in broad daylight is risky, especially if you're neither fast nor big. Scavenging predators are a constant threat, and this is when the walking cuttlefish shows its true colors. Aptly named the flamboyant cuttlefish, it puts on an alarming display.
When something comes too close, they'll flare up the arms and they walk around flashing these colors and advertising these really bright color patterns. And I think this is advertising the fact that they're poisonous to eat. If anybody gets too close, even like a diver, they show all the bright colours and it says, back off, I'm poisonous. It's either pretending it's deadly as hell and trying to mimic something else that's dangerous, or it's walking around confident that it itself is deadly.
Clearly, the flamboyant stands out from the rest of the cuttle pack. But is it just a big bluff? Or the real thing? Is it poisonous? To find out, Mark and Ronald need to look for a fully grown animal, and freshly laid eggs are the best indication that a mature female is around. Hidden under coconut shells, they find flamboyant eggs already well developed. The mother can't be far off. It's a challenge for a flamboyant mother to find a safe spot for her eggs. Without rocks or caves, old shells are the next best thing. Compared to the egg-laying frenzy of her giant cousins, hers is a quiet affair. She lays up to 100 eggs, a truly exhausting task. And with the laying done, she'll soon die naturally. But there's one more important mission she can help with, assisting Mark with his toxin studies.
If this animal does turn out to be deadly, to be toxic, it will be the first cuttlefish in the world that's known to be poisonous. We could be seeing a whole change in the evolution of these animals. I'm really fascinated on what it is about them that's poisonous. Do they have a poisonous bite? Is all their flesh poisonous? Can they squirt poisonous ink?
Mark has to take her back to Venom Labs in Australia to unravel her potentially deadly secret. The winter storms have finally passed, and the deserted mating grounds of the giant cuttlefish slowly begin to warm. The parents have died more than 3 months ago, but the next generation of giants is about to start their lives. Sheltered in their rocky nurseries, the eggs have grown pin-sized embryos. Sucking up energy from the yolk, they've grown 8 arms, red dot eyes, and their family trait, the cuttlebone. In the final month, the embryo's eyes fully develop, and, still hanging upside down, they start wriggling around. By now, the egg's soft shell is stretched to double its size, and the bodies have outgrown the yolk ball. Once they start floating upright, the little giants prepare for the outside world. All their organs are now developed, and they can already change the color and shape of their skin. To break free, they squirt a special acid from the tip of their tail to burn a hatching hole through the rubbery shell. Barely the size of a fingernail, the tiny giants emerge like miniature adults, with suckers, ink, and all. Nobody knows how many will survive. In a few days, they'll start hunting tiny shrimp and perfect their shape-shifting repertoire. But they've got to watch out. They're on the menu for almost anything with a fin. Sharks, big fish, seals, they're all after them. Their meaty bodies, without spines or armor, make cuttlefish a protein-rich meal. Camouflage is the cuttlefish's main defense. While they're invisible, they're safe. But once the cover is blown, their only chance is to disappear behind an inky cloud. Dolphins have developed a special taste for cuttlefish. But rather than gorging on the whole body, they prefer to just pick off their soft arms and heads. Leaving behind tattered bodies, they provide a free meal for many more creatures. But cuttlefish don't only end up on nature's menu. Our ever-growing appetite for seafood makes us one of their most voracious predators. Cuttlefish, octopus, and squid are eaten around the globe, harvested on a large scale. The total reported world catch is more than 3 million tons per year, worth more than $6 billion annually. Our taste for all things calamari overwhelms even their best camouflage. Back at Australia's Institute for Molecular Bioscience in Queensland, Dr. Mark Norman is about to solve his latest cuttle quest. Is the colourful flamboyant cuttlefish just a poser or poisonous?
That's worth looking at. Toxicity is really rare in these sorts of animals. There's thousands of species of octopus, squid and cuttlefish, and in all the world there's only blue-ring octopuses, and just recently the little striped pajama squid are the only ones that are known to be poisonous, to be very deadly. And so trying to understand the behaviour of this strange little cuttlefish, I think it's really important that we find out whether it's pretending to be something else that's dangerous or it itself is dangerous.
Toxins could be anywhere, from the skin to the inner organs. If the flamboyant's bite is toxic, its saliva will contain the poison, just like in the octopus. But it could also be mixed with its ink. Mark needs to look at tissues from all body parts. The samples are chemically analysed to detect and measure toxic traces. And then the big news.
Well, it turns out the flamboyant cuttlefish is toxic. It's as toxic as blue-ringed octopuses, and blue-ringed octopuses have killed humans from their bites. So we've got the first deadly cuttlefish in the world, and it's amazing on a couple of levels. First of all, it's actually poisonous flesh. The muscles themselves are poisonous. So this is the first time that flesh that is deadly has been reported in any of these groups of animals. And secondly, the toxin itself is not known. It's some completely different class of toxins. And toxins like those could be the key to whole new discoveries for lots of human medical conditions.
Marine toxins are a new frontier in biodiscovery research, attracting attention from the global pharmaceutical industry. Manufactured in laboratories, the flamboyant's novel toxins could lead to powerful new drugs to treat chronic pain in cancer or arthritis sufferers.
This is a fantastic result because it makes sense of what we're seeing in the wild, and this toxicity, this poisonousness, is probably what's underpinning the whole weird behaviour of the animal, and the fact that a group of animals that normally swim around or spend a lot of time trying to be camouflaged have become so obvious, have given up swimming, are walking everywhere. It's like a major step towards a whole new line in the evolution of these animals.
Evolution means change, so maybe in a few million years, the flamboyant will march on 8 legs onto the beaches. Or the Broadclub will hypnotize its enemies as well as its prey. Perhaps the giants will invent even more daring strategies to outwit their rivals. Cuttlefish are amazing and clever creatures.
I think if we could understand why cuttlefish have evolved such large brains and such ability to solve problems and learn, It might tell us a little bit about how come we evolved such abilities. How did we end up with the head that we have between our ears, and what happened in our past that got us to where we are today?
Cuttlefish research is still in its early stages, and we don't yet know where this brainy bunch could take us.
We are testing an animal that's very alien. I mean, it's as close, perhaps, as we're going to get to studying, at least that I'm going to get to studying an animal on another planet. And is that exciting? That's very exciting.
These bizarre creatures hold many more fascinating secrets, and Mark still has a lot to discover.
I hope in my 80s and 90s I'm still wandering around underwater with a walking frame following these things around, because it'll take 100 lifetimes to get a handle on these animals.
Alien they may seem, but the brainy bunch has thrived on our planet for much longer than we have. Think about it.